Alright, in this video we will discuss how to break vectors into components. It's important to know how to do this, particularly if you would like to add vectors by their components. So we'll discuss a few simple steps to break these vectors down into x and y components using a couple of simple trig functions. So let's get started. If we have a vector of 52 newtons at 13 degrees above the positive x-axis, if we'd like to break this vector into x and y components, the very first thing that we should do is draw a picture. So step one is to draw a picture of this vector. We'll lay out our coordinate system. And we'll have positive x, positive y, negative x, and negative y. And then this vector is 13 degrees above the positive x-axis, so we'll draw it about like this. 13 degrees, and it had a magnitude of 52 newtons. So we'll go ahead and label that. Alright, so step one was to draw our vector. Step two is to identify your given angle, and this is it right here. So we know that this is our given angle. Okay. Step two. Step three is to identify each component and whether it is opposite or adjacent to the angle. So step three is to identify your components. Identify components. So we'll notice that we have a component here next to this angle, adjacent to this particular angle. And this will be our x component. It's good to go ahead and indicate direction. This arrow is pointing to the right, our vector is pointing to the right, so this x component will point to the right as well. We also have this component that is opposite the angle, and it will be our positive y component. And this will be our x component. Now this y component will be positive because it points up, and the vector's pointing up. We would say that it is pointing up and to the right, so our y component must be positive, must be pointing up, and our x component must be positive as well, must be pointing to the right. So now that we've identified our components and whether they are opposite or adjacent, let's go ahead and mark that. This is opposite, and this one is adjacent to our angle. Then we can use a few trig functions to find the magnitude of each component. So step four is trig. Right. So we will use sine and cosine here. We'll use sine to find the side, the magnitude of the side that is opposite our angle. Okay, the big end of this ice cream cone, if you will. So let's go ahead and do that. We'll say sine of our angle, which is 13 degrees, sine of our given angle, multiplied by the magnitude of our vector, which is 52 newtons. That will give us some number, and that will be our y component. So let's plug this into our calculator. Sine of 13 times 52. It's important to make sure your calculator is in degrees. It's important to make sure it's in degrees. So we get 11.69. 11.69 and that's good enough to be, call that 11.7 newtons. And that is our positive, or our y component. Okay. So then we'll use cosine to find our x component. And the formula is very similar. Cosine of 13 degrees times our vector magnitude, which is still 52 newtons, is equal to something. We'll put this in the calculator. Cosine of 13 times 52 gives us 50.7, we'll call it, newtons, and that is our x component. So, at this point, we need to double check the sign on our components. Our x component has to be positive. Remember that the sign does not necessarily indicate greater than or less than 0, but in physics or with these vectors, it's indicating the direction. So this x component must be positive. So our x equals positive 50.7 newtons. And our y component equals positive, because it goes up, positive 11.7 newtons. Be sure to check out our videos on adding force tables, or solving force tables, and also on adding vectors, now that you know how to break them into components. Thanks for watching.